We're going to talk about DevOps. And it's been, 15 years since DevOps thing, and we still talk about DevOps, and you're still here, which means if you're not sure what DevOps is, you're not alone. I'm going to introduce a conspiracy theory to you. I hope we will be somewhere, where is my, it doesn't work. Okay, somewhere around like the green area, definitely not going into reds. But hear me out. The conspiracy theory is as follows. DevOps is a plot of ops people to make us, the developers, work harder. Do you agree? Of course you agree. Good. All right. So my name is Baruch Sadogursky. I'm a JBaruch on the internet's developer productivity advocate with Gradle. My personal history, I started as a developer many years ago, and then with the company called JFrog, we went all the way to DevOps, did a lot of stuff with DevOps, and now I'm kind of back on the developer part of the house with Gradle, dealing with developer productivity engineering. I read a couple of books. DevOps tools for Java developers is particularly relevant for this talk because it's about DevOps for developers. So that's kind of, I hope I know what I'm talking about. And Liquid Software, another book about software delivery, which is also kind of related. Okay, the most important slide of this talk is this one. If you go to speaking.jbaruch, you will find there the slides, they're already there. The video, which I record right now, hopefully, and I will post it later. All the links for everything that we're going to talk about. And to make it easier on you to remember, it's on the bottom of every slide, together with Twitter handle, hashtag for JCon 2024, and DP for Developer Productivity Engineering. You will see the relationship later. Okay, this is the QR code for the app of the conference to ask questions. You can obviously just ask questions. You know, that sometimes it's just over-engineering. You just can just ask questions. Okay, and anyway, that's a way to do it. Right, so as I mentioned, I started as a developer very long time ago, and then went into DevOps. So I know what's going on. I was one of the few people who could uncover the conspiracy, right? Because I kind of observe it from both directions, and I'm going to share it with you. It's actually pretty obvious what's going on if you look very closely at the evidence. And the first piece of evidence is the Phoenix project. I would say that's the most important book about DevOps. If you want to read one book about DevOps, that should be it. It's really, really good. And it's basically a novel about a company that was failing. And then there was one guy who kind of invented DevOps and saved the entire company. Right? How many of you read the Phoenix project? Okay, not enough. The rest of you definitely should read it. It's a great book. All the evidence that we need that we have a conspiracy theory is actually on the cover. Now, you can see on the cover there are people, and those are the main characters in the book, and we can just look at them and see what's going on. So it's a little bit small, so I'll read it from here. We start with Patty. She is the director of IT service support. IT service, it's ops. And then there is Wes, who is director of distributed technology ops. He's in ops. And then there is Sarah. She's like the antagonist. She's like the bad in the story. And she's obviously sales and marketing, of course. And then there is Steve, who is the CEO and also CIO. That's fine. And there is Dick, who is the CFO. Okay. This guy, Bill Palmer, he's the main protagonist. He's the main hero who actually invents DevOps. And he is VP of IT Ops. He's obviously an ops guy. And then there is Eric, who is a board member. The story goes that Eric kind of gives Bill, all the clues that Bill needs to discover DevOps and save the company. And then there is Brett, lead sysadmin, obviously ops. And then there is like a security guy who hides in the back for a very good reason. You should read the book. In any way, something stands out? Huh? What's going on? No developers. No developers. Not a single developer. Well, there are developers in the book, not pictured in the best light, trust me. Those are the people who kind of at 5 p.m. drop the pen or the keyboard, just go home. Like they don't care about anything, and it's like the ops people need to engage them in DevOps in order to get them interested in something beyond just writing code. Okay, so that's a very kind of a strong hint. Let's look at another one. Who teaches us about DevOps? Let's look, when we Google what is DevOps, let's see who pushes DevOps. So we have, first of all, Amazon. Amazon Web Services is an ops platform. And then we have Atlassian. Atlassian is a set of DevOps tools. And then we have GitLab. They call themselves the DevOps platform or DevOps in the box or whatever, something DevOps. And then we have Microsoft with Azure, which is an ops platform. And then we have TechTarget, journalists fine, Wikipedia fine. And then we have Synopsys, again, ops tools. And then we have Logs.io, ops observability platform. And then we have IBM, who wants to be like all the cool kids and do DevOps as well. So basically, it's pretty obvious. When you look at DevOps, they're all ops. They're all ops people who try to sell DevOps to us. Now the question is why? Why do they try to sell DevOps to us, the developers? What's the interest? Well, maybe it's about money. So here's a question in Quora. As a Linux administrator, how do I shift my career to DevOps? And there is like a DevOps consultant that basically goes like, hey, you need to learn a bunch of ops stuff, like Linux administration, right? Like cloud computing, base of ops stuffs, and then something that is called Gits. Basically, if you know a bunch of ops stuff and Gits, you are a DevOps engineer. Okay, fine. But what does it mean? Well, first of all, it means that if you used to have this salary as a system administrator, you're going to make much more as a DevOps engineer. And all you need to do is learn system administration in Gits. And here you go. Now, obviously, next thing you know, there are hundreds of, tens of thousands of open positions for DevOps engineers because everybody needs DevOps engineers, everybody want to be DevOps engineer. And then next thing you know, there is money, let's make more money in certifications. Let's do certifications for DevOps engineers and all this kind of stuff. So it's basically about money. Maybe they try to push DevOps because there is money in it. Well, not really. The problem is when DevOps started 15 years ago, no one knew it's going to be a treasure trove of money and everybody will make money from DevOps, right? It was like completely not obvious. So that's not the reason. The reason is something else. This is what it's called the DevOps Infinity Circle. And if you look close at it, it reminds something else. What it reminds of. That looks very familiar. What does it remind you of? This. Basically, it's almost the same thing, right? So it was like plan, code, build, and test, which is exactly the same thing, but also release, deploy, operate, and monitor. It's like someone took the work of developers, slapped all the work of operators, and called it, hey, now it's your job. Good luck. Let's look at another very damning evidence. State of DevOps report. State of DevOps report is the most important kind of a report or study in DevOps world. It's done every year for many years right now, I think like more than 10 years or about 10 years. And at the moment, it's run by Google Cloud, Ops platform, of course. Started in what was called the DORA Institute, DevOps Research and Assessment Institute. But now it's all Google. So there are very interesting and insightful findings in the report. This from the old one, but there is something that I want to show you here. So you see how the first line is new work. It's kind of marked. And it's marked for a good reason, because new work is where the money is. Right? This is what we want to do. When we work for whatever our work is, new work is the most important part. And obviously, the goal of any process is maximize new work and comparing to everything else. Now, this is all very valid. The question is how work is defined. And we can find the answer in the DevOps report, and this is very profound. So, types of work according to DevOps, according to State of DevOps report and the Phoenix project book and many others. So there is planned work, and that's the new work, and it's business projects or new features. So far, so good, but then it kind of becomes very weird. Internal project, server migrations, software updates, and so on. This is something that ops people do, right? And then there is changes driven by feedback on completed work, fine. And then again, unplanned work is support escalation and emergency outages. I mean, this is all very fascinating and fun, but it has nothing to do with the developers. Right? We don't do support escalations and outages. What do? Well, for new features, we write code. For refactoring, we write code. And then we fix bugs, we write code. There is no server migrations. There is no outages. We write code as developers. The whole idea is that somehow outages and software updates is a part of our job is exactly the proof that DevOps is an elaborate plot of ops people to make us, the developers, work harder. And it's crystal clear, right? Point made. We're done. We can go to lunch. Thank you very much. All right. What is our job now? Well, I guess it's very clear that ops part is not our job. What is our job? There are many definitions of what developers do. One of them that I personally like is the manifesto of software craftsmanship. There are some issues with the manifesto, with the authors, with the bunch of stuff, but I think the content is very solid. Because if you look at the content, I mean, no one will argue that we just don't want just to write code, we want to write good code. And instead of just responding to change, we want to add value. And instead of just being individuals, we want community. And instead of just like working together, we want productive partnerships. I guess this is very, very clear that everybody can get behind it, regardless of who wrote those lines. Now, if we look closer to those points and kind of try to break them down to action items, what done looks like for the developers, we can come with a nice list, and that's what I call software craft person definition of done. So what is it? We understood what we need to do. Our code is clear. Our code is easy to deploy. Well, we are not ops people, but we do have partnership with the ops people. We want our code to be easily deployed to production, obviously. Non-functional requirements are met, stuff like performance and scalability, etc. No new technical debt. Maybe we did refactoring, cleaned some old one on the way. The tests are passing. Not only that, quality assured people are happy with our code, which is more than tests just passed, right? It's basically that they looked at the code, it's maintainable, it's testable. Well, I mean, it's good code. And then team lead is happy with our processes and what we've done. And then product owner is happy. And product owner is the delegate of the customer. So if the product owner is happy, the customer is also happy. Right? So far, so good? Everybody can get behind it? Excellent. Now, here is a very old image about the rivalry between developers and testers. It's old. It's like 15 years old. I want to ask you if you still think that this is relevant. How many think that there is a rivalry between developers and testers? Well, a couple of people, and not all of you, for a very good reason. It does not exist. Testers are not our enemies. Testers are friends. Testers help us write better code. And we just spoke about it. We want to write good code with good quality and that passes, that makes the QA happy. That means that they help us and this rivalry does not exist. Instead, we as good developers strive for quality. Now, the thing is, what quality means changes over time. And I will give you an example. If we go back in time and look at something that was an acceptable quality many years ago, I think this is 2007, and that makes it, what, 14 years ago. That's a website of Chase Bank, and that's my bank. And back then, the website was not very useful, right? You can go there, you can check the balance, you can like see what's going on, but you know what? If something went wrong, it wasn't a big deal if the website didn't work. And there is like news over there, and one of the items might be the website is going down for 12 hours for update to improve quality. And we were like, okay, does it mean that the website is bad? No, not necessarily. It was okay then, but now? How about a bank website or an app that is down for 12 hours of maintenance? This is something completely unacceptable because quality, what quality means changed. Not only that, there is also a lot of data, like a lot. This is a projection done by Seagate. Seagate might be a little bit biased. They sell storage, so the numbers might be a little bit off. But in any way, even if we take it with a lot of salt, 175 zettabytes of datasphere by next year, 2025, is a lot. So what's big data for you? When you think about big data, what units are you thinking of? What is big data? Petabytes, thank you very much. Now, zettabytes are not the next scale. There is something else that I forget the name. What's come after petabytes? Someone remembers? Exabytes, thank you. So there is exabytes after petabytes, and then there is zettabytes. So 175 zettabytes is a lot of data. And that was before they knew what LLM is going to do to our data. So they probably maybe underestimated. In any way, what I try to say is, even smaller companies are now dealing with staggering amount of data. And one of the effects of having all this data is that setting up an environment which mimics the production, including all the data in production, becomes less and less feasible for more and more companies, just because there is too much data to mimic in the staging environment. And that basically means that the concept of staging server, which is exactly like production, but we can test it before we roll it out to our customers, is dead. We can either do environment which not be representative of the production, which kind of defeats the purpose of staging server, or we can try and do something that is representative on production, and it will be just too expensive, too slow, too hard to obtain. So basically, the staging server is dead, and we don't have the environment to test on. So what do we do? What do we do? Except of panicking. What do we do? We test in production. Thank you very much. There is an entire industry now of testing in production. It's called progressive delivery. There is a bunch of fascinating terms, and my favorite, by far, is blast radius. It's great. It means that we're going to throw something that will explode for sure. And all we try to do is minimizing the risk. Right? So there is no even that they don't even try to hide the fact that things will break in production. It's all about how bad it will be, how large the blast radius will be. And there is an entire industry about minimizing the blast radius. Canary deployment. Let's take some people. Yeah, you know the story about canary deployment, why it's called canary deployment. Back in like 100 years ago, miners in coal mine sent a canary, like a live bird, into the mine to see if there is gas poisoning inside. If the canary survived, everything is fine, there is no gas poisoning, they come in. If the canary died, then there is a problem and they shouldn't come. So basically, what canary deployment means is that some of you randomly assign the role of canary. You are going to die because of gas poisoning, so other people won't come in. They don't even try to hide how bad it is, the whole idea of testing in production, but this is what we do. Now, for us, the developers, what it means is that if we care about quality, we have to be there where the rubber hits the road. We need to be there where there are casualties in production, and we have a blast radius. Who is in charge? Who is in charge of the quality of our code that misbehaves in production? We are. So, welcome to on-call. If we have to be there when our customers try our software for the first time, this is where it happens. It happens in on-call. Now, it also brings more responsibility to us as developers. If the code is only tested in production, we need to make sure that there is one more item on this list. And then our code is DevOps ready. It's ready to be tested in production, which means that there is more stuff that we need to take care of. And that's another list that it's similar to other concepts around DevOps, like cloud native or 12-factor app or others. And this list contains of stuff like clean deployment plan. Imagine you are on call, there is a blast radius, there are casualties, our code doesn't work. Does anyone know how to deploy our code? We hope, but we should have a plan. Stuff like stable and fast build. And, Gradle, send me here, pay for me being here, and this will be a shameless plug. If you want fast and stable build, you should look at the Gradle build tool that might make your build fast and stable. Stateless code, not always achievable, but stateless code has a great advantage of being very scalable. If we are now rolled out our code and the load is too high, we can always scale code which is stateless, not like it has less state than stateful. Okay, fast startup and stop times. This is very important because if we have a version which misbehaves, we need to kill it, and then we need to start another version, either a previous one or fixed one, whatever. The stop and startup times are critical, and this is where modern Java development frameworks and tools come and help you, like Spring Boot, like Micronaut, like Quarkus, all those frameworks that start really, really fast. Observability. You know what? It would be nice if you know that your code doesn't work, not from Twitter. Right? And observability definitely helps. Feature flags. You know what? There is a feature, it doesn't work. Let's just turn it off. You do it with feature flag, and then the part of the website or your application that doesn't work, you can just turn it off. This is very nice. Backwards and forward compatible microservices. You might end up in a situation in which newer, older code has to work with newer code without knowing how new code works, because you had to roll back a microservice. So you need to think about this kind of stuff. Event streaming, again, goes into observability. It would be nice to know that something happened before it happens. So basically, all this work is suddenly your responsibility. And unfortunately, there is no way around it. How do you feel about it? Nah, not so great, right? And DevOps people are trying really hard to convince you that it's fine. And that's not because they're evil or lazy. It's because we don't have a choice. Right? We just spoke about it. We don't have a choice because in modern environment, we don't have the luxury of throwing the keyboard at 5 p.m. and go home. We don't. And the reason, and the only question is, how can we live with it better? How can we be more excited about DevOps than just this? Now, funny story about this slide. If you search through GIFs in the internet, there is no GIF that goes from sad to happy. There are a lot that go from happy to sad. People are realizing, oh shit. But no one goes from being sad to being happy. But this is something that we need to do. So I had to reverse the GIF. And it looks really awkward. But, you know, you do what you have to do. One of the ways for us to feel better about DevOps is to start looking at it from different direction. So 15 years ago, you might seen this. DevOps is something between DevOps and QA. Well, what does it mean? No one really knows. Maybe it's just people who understand DevOps and QA all at one, like those unicorns that, you know everything about everything. And of course, by now we know they don't exist. So another way to look at DevOps is something about people, something about better processes, and something about better tools. Something like this is better. This is better because it is people working with tools under a process. Okay, but what? Productive people, productive processes, and productive tools. Now this already makes a lot of sense. And it makes a lot of sense for all of us in dev and in ops. And actually this is DevOps. So if we can build processes that will be productive on how we work together, dev people and ops people, and we will find tools that allow us to collaborate, including an on-call under stress when the production is down, there is blast radius, canaries are dying, and what's not, right? And then find a way for us as individuals to be productive. This is, in essence, DevOps, right? So processes, we figured it out. It took us the longest time, but now we know what empowered team is. It's basically the opposite of silo when everybody works separately. It's the team that is built from dev people and ops people and QA people and security people and product and product owners. And it's a team that can deliver the entire value stream from the inception, from the idea, all the way to working in production together. Perfect, we got it. Tools, well, kinda, sorta, not really, but okay. We have tools that considered productive by some, and it is what it is. How about productive people? Are we as productive as we can be? And the answer is, trust me, we're not. Developer pains are widespread. What it is, almost 90%, 84% say that too much time is spent waiting for build and test feedback, either locally in CI. Who thinks that their build can be faster? I get 84%, I get 84%. Perfect. Okay. How about inability to easily troubleshoot and determine the root cause of build, test, and CI failures, including flaky tests? The stuff is failing. I'm not sure why. There are flaky tests that are really annoying, this kind of stuff. Well, I think you're better than most because my number here shows 65% and I saw about maybe a third. And how about inefficient observability of analytics on build and test performance, failure tests, and productivity bottlenecks? I have no idea what's going on in my complicated build. Okay, that's all the people who understood what this is about even. Okay, yeah, pretty much. So there is a problem with our productivity as developers, and it's not our fault. It's just everything is fucking hard. Because software is hard, and our systems are getting more complicated, and we cannot understand what is going on in all this crap. It's okay. There are tools and ways for us to become better, and what we at Gradle advocate called developer productivity engineering. Developer productivity engineering is the idea that we can improve developer productivity through engineering. And there are 7 tenets, 7 ideas that if we pay attention to, our life as developers will be better. First is foster faster feedback. It took me 2 months to figure out how to say it really fast. Foster faster feedback. And I'm really proud of myself now being able to do that. Foster faster feedback. Faster feedback, faster, okay. So close. Faster feedback loops. Less waiting for builds, less context switching, less wasting time and mental energy throughout our day. Eliminate toil for developers. Okay, toil is everything that we really shouldn't do, but we are doing. If we shouldn't do it, we shouldn't do it. We should eliminate it. We should automate it. And this is done through automation. We'll get to it in a second. Collaborate through effective tooling. Getting back to Gradle, your Gradle build is now failing. How easy it is to express to your colleague that might help what actually happened. It's terrible. What do? You copy the log files, you share the screen, and then scroll through log files. It's a disaster. There is a better way. There are tools that can allow you to collaborate efficiently. Prioritize automation and elimination of bottlenecks. This is actually from DevOps handbook. Ops people do it for production environments. They automate everything so we don't need deploy by hand, and they eliminate bottlenecks in deployment. But how about our development environments? Does anyone think about how can we work better by automating and eliminating bottlenecks? Embrace rigorous observability for productive improvement, from proactive improvement. Observability, we spoke about it. We prefer to know what's going on in production. But what about our build and CI? Do we have observability there? Do we know how our local builds in our team, in our organization are doing? Probably not, but we really should. Dedicated organizational mindset, that's a big one. So everybody pay attention to production, because this is where the customers live, this is where we get the money. Who pays attention to local environments and how you, the engineers, are doing? Probably no one, because you'll figure it out, but they really should. And outcomes over output. Remember the build log? Wouldn't it be nice to actually see what went wrong instead of all this? So basically, paying attention to those can make your life much easier and make you much more productive. And without that, there is no DevOps. So, is DevOps against developers? Well, as established, and jokes aside, DevOps mainly solves ops concerns by making processes and tools more effective. The empowered tools and the empowered teams and the cloud native tools are there to make your production more effective. But developer productivity engineering is the missing piece to make developers more productive and to better participate in the entire DevOps story. So this is how we bring developers into DevOps without just generating more hate towards the ops people. And with that, you can scan this QR code. It will take you to Speaking at Baruch, which is where, as I mentioned, you find all the links. I can show you some of this stuff if you go there and take the Gradle and Maven Speed Challenge, and that will be improving your build and observing your local environment. I would like you to spread the word about developer productivity engineering in your organization, and maybe read the Developer Productivity Engineering Handbook, which is also very, very good resource. DP Summit is a conference about developer productivity engineering. It's happening in September, and you should check it out. There are also DPE events local in different areas. The ones that are come up in Europe, and if you are in the area, you should definitely take a look at them, are London and Berlin. It's a short train ride. You should definitely take it and come. It's free event about developer productivity engineering. And with that, thank you. At JBaruch everywhere, or whatever social media is trending this week. JCon 2024, that's the hashtag to praise this talk when you take it to the internets. And Speaking in JBaruch is where the video, the slides, all the links are living. With that, thank you very much. And we have time for questions, a little bit.